Good evening students. Today we are going to discuss about the Model 3 Embedded System Components. The topic is Sensor and Actuators. An embedded system is in constant interaction with the real world, and controlling and monitoring the functions are executed by the embedded system is achieved in accordance with the changes happening to the real world. The changes in the system environment or variables are detected by sensors connected to the input port of the embedded system. So input port, in the sense, sensors plays the actual role and actuators plays the output role. If an embedded system is designed for any controlling purpose, the system will produce some changes in the controlling variable to bring the controlled variable to the desired value. It is achieved through an actuator connected to the output port of the embedded system. So, embedded system which needs of input as a sensor and output as an actuators based upon the application. If the embedded system is designed for monitoring purpose only, then there is no need of including an actuator in the system. For example, take the case of ECG machine. It is designed to monitor the heartbeat status of the patient, and it cannot impose any control over the patient's heartbeat and its order. The sensor is used here for the different electrode sets connected to the body of the patient. Variations of the heartbeats are captured and presented to the doctor through the visual display or some printed chart. So sensor is a transducer device that converts energy from one form to another form, like any measurement or control purpose. The sensors may not be directly interfaced to the input ports. Instead, they may interface through the signal conditioning and translating systems like ADC, optocouplers, etc. So these are the various types of the sensor. We have a color sensor, we have gas sensor, LDR, light sensor, proximity sensor. Normally in mobile phone we are using that proximity sensor. Whenever you are making call, that time if you are taking your mobile phone near to ear, your ear, okay, immediately what will happen in the sense, the display will be turned off. Okay, so that proximity sensor very much useful in that situation and that conditions. And we have a thermistors, we have a heartbeat sensor, rain sensor, water flow sensor, IR receiver, ultrasonic sensors, soil moisture sensor, gyroscope, photo transistors, humidity sensor, touch sensor, IR sensors, transmission type and reflection type. Various types of sensors are available in the thing. Mainly automotive Ford cars, nearly 75 sensors are used, or 75 embedded systems are used in that automotive electronics. Next, actuator. What is actuator? Actuator is a form of transducer which converts the mechanical energy or electrical energy in which converts into the signal corresponding to the physical action motion. This is also which will convert the one form of energy into the another form of energy. That means from mechanical motion to the mechanical or electrical energy to the corresponding physical action. For example, some of the actuators are there: LED bulb which creates the light, heater which increases the temperature, cooling unit, motor, pump, buzzer. These are the, we can say that, actuators. Actuator is also called as a component of the machine that is responsible for moving and controlling the mechanism of the system. For example, opening a valve. In simple terms, it is a mover. We can say that when it receives the control signal, an actuator responds by converting the signal energy into mechanical motion. Very good example for that sensor and actuator I can give that your air conditioner. Air conditioner, we have a sensor. Based upon the room, the temperature will be identified or detected by the sensor. That will be given to the processor will give the information to the actuator to run the compressor. So actuator is nothing but output and the sensor is nothing but the input for the measuring. So actuator is normally acting as a output device. Some of the devices will see that output devices we can see here is light emitting diode. What is light emitting diode? It is nothing but LED. Is an important output device for visual indication in any embedded system. LED can be used as an indicator for the status of various signals or situations. Typical examples are indicating the presence of power conditions like device on, battery low, or charging of battery for a battery operated handheld embedded devices. Light emitting diode is a PN junction diode. It contains anode and cathode. Proper functioning of the LED or anode of it should be connected with the positive terminal of the supply voltage, and cathode should be connected to the negative terminal of the supply voltage. That means biasing, it has to be given properly. That means anode has to be connected to the positive supply and cathode has to be connected to the negative supply. The current flowing through the LED must be limited by the value before below the maximum current that it can conduct. So this is nothing but the LED. VCC is connected. There is a resistor is used. There is a resistor is used in series with the between the power supply and the ground to limit the current through the LED. LEDs can be interfaced to the port pin of the processor controller in two ways. First method is nothing but anode is directly connected to the port pin and the port pin drives the LED. In this approach, the port pin sources the current to the LED when port pin is at logically high. Second method is nothing but cathode of the LED is connected to the port pin of the processor and anode is connected to the supply voltage through the current limiting resistor. The current is directly sourced by the power supply and the port pin acts as the sink for the current. Here we will get the required brightness of the LED. The LED is turned on when the port pin is at the logic 0. Here the port pin sinks the current. Next one is a 7-segment LED display. So 7-segment LED display is an output device for displaying the alphanumeric characteristics. We have 8 LED segments arranged in a special form like A, B, C, D, E, F, G, and we have a DP decimal pointer also. Out of LED, 8 LED, 7 LEDs are used for displaying the alphanumeric character and one is used for representing the decimal point in the decimal number display. The LED segments are named as A, B, C, D, E, F and DP, G and DP, and the decimal point LED is named as a DP and should be lit accordingly to display the numbers and characteristics. For example, the 4 is the number to be glown in the LED in the sense F, G, F, G, B and C are in on condition. For 3 will be displayed in the sense A, B, G, C, D. This and DP will be on for the A for the segment to display 3. If D is displayed in the sense, so for that D is the character has to be displayed in the sense, then B, C, D, E and G, small d. Okay. So B, C, D, E, G are in on condition. All this 8 LED segment need to be connected to one port of the processor or a controller for displaying the alphanumeric digits. 7 digits of LED display are available in 2 different configurations, namely common anode and common cathode. In common anode configuration, the anode of the 8 segments are connected commonly, whereas in common cathode connection, 8 LED segments shares the common cathode line. Based on the configuration of the 7-segment LED, the LED segments of anode or a cathode is connected to the port of the controller in the order A segment to the least significant port pin and DP segment to the most significant port pin. The current flow through each of the LED should be limited to the maximum value of supporting the LED display. The typical value of the current falls within the range of 20 milliamps. The current through each segment can be limited by connecting the current limiting resistor to the anode or cathode of the each segment. The value for the current limiting resistor can be calculated using current value from the electrical parameter listing of the LED display. For common cathode configuration, anode of the each LED segment is connected to the port pins of the port to which the display is interfaced. The anode of the common LED display is connected to the 5-volt supply voltage through current limiting resistor, and the cathode of each segment is connected to the respective port pin line. For LED segment to light in the common anode LED configuration, the port pin to which the cathode of the LED segment is connected to the should be set at the logic 0. 7 segment LED display is popular device for low cost LED embedded applications like public telephone monitoring, IO interface devices, point of sale terminals, even in bus displaying there for displaying for numbers and for places. This 7 segment LED is used. This is nothing but the common anode connection, and this is the second one is nothing but common cathode connection, where the cathodes are commonly connected and anodes are connected like from A to Z, and last one is a DP decimal pointer. In common anode display, that anode will be connected as a commonly, and A to G is connected for the LED segments, and DP is nothing but the decimal pointer. Thank you.